Very good evening, everyone. Can you all hear me? Please react with a thumbs up yes in the chat if you can hear me. Awesome. So I can already see a few people messaging in the chat. So welcome everyone to this session, first session of this year. And I hope you have had 1 week of sessions earlier. So very happy new year to everyone. Aditya, Shobhi, Sevaswa, Hari Prakasham. So I can see that you people already responded in the chat. Welcome to this session, everyone. Can you also react with a quick thumbs up if the screen is visible to you? Awesome, awesome. So Venkat says yes. Awesome. Sunil says hello, Sahil, looking new and fresh, nice and fresh. Yes, yes. Thanks, Sunil. Yes, Jagrut. Very happy new year and welcome to this session, everyone. Last session was in 2021. Yes, 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 Ram. Awesome. So let's quickly get started with this session then. I hope you all are ready. You all have a pen and paper with you. Thumbs up if you have a pen and paper with you. Sahil Jindal says hi. Hi, Sahil. Same name. Yes, some of you don't have. So if you can have a pen and paper, it will be really great because we'll have some quizzes in between the session. I'm doing great, Sai. I hope everyone is doing good, taking care of your health and staying safe. Yes, Vishal says just 2 minutes. Take 2 minutes, everyone. Hi, Venu. So let's quickly wait till everyone has a pen and paper and we will get started with this session. So what all have you learned till this point? So you have had 3 sessions in the last week, right? So what were those sessions about? The first session, or like how many sessions have you had till now? Just one session. Okay, 2 sessions. Got it. Dare to Dream was one session. Got it. Got it, Gaurav. With Rishabh too. Okay. Great. Great. Shanti, Nag Subramanian. Yes, yes. Dare to Dream and one more. Mang. Okay. Jatin says this is my first session. Yes, yes. So this is our first session of the intermediate content. So this is our first session of the intermediate content. Yes, we are starting with the content today. Okay. Okay. Abhishek says we are from beginners batch, first class in intermediate. Oh, that's great. So we also have some people joining from the beginners batch. So welcome everyone if you are in the November beginners batch. So we are starting with the intermediate content now, right? So I think Prateek must have been teaching you earlier, right? Okay, got it. So we have some people from the beginners batch, some people who have just joined. So depending on that, yes, understood. Okay, so let's get started now. So I'll start with the agenda of this session and then let's have a brief introduction about everyone. Then we will get started. So I hope you can see the screen crystal clear. So basically, a few notes before we start, a few points before we start the session. So I'll just copy and paste them in the chat. So whenever you are answering a question, so wait, let me just message it like that. So answer the questions privately. In the to field in the chat, you can select the name of the instructor. You can see my name at the top. So whenever answering questions, answer it in that way so that others can think independently. Whenever asking questions, can you all see the questions tab right hand side, third icon, questions tab? Thumbs up if you can see that. Awesome. So always keep your questions in that questions tab. If you're on mobile, you might be able to see that by maybe hovering to the right hand side. So for mobile users, just verify it once, but you will have a questions tab and you can use these reactions as you're using to acknowledge. So this is very common thing that we will follow in all these sessions. And if you're just going to refresh your Python knowledge, so if you want to refresh your Python knowledge, that then we also have, let me just paste it here. We have optional classes in the all classes tabs, right? In the all classes tab, you will have an optional heading. There you can also take a look at some Python content that you can go on as your own pace. So most of the people who are in the intermediate batch will already have some Python knowledge, right? So we will be writing the pseudo code in the class. We won't be writing actual code, but it will somehow, it will be correlated with the Python code, so that you don't have any difficulties implementing the solutions, right? So these are two things before we start with this session. Okay, so anyone has anything before we start? Anything before we go over what we are going to learn, and anything that you want to say before we start? So Venkat, we will be uploading the notes. We will be uploading the notes in the classroom. So I do not want you to take everything, write everything, just the key points you can take down, just so that you can revise them. But your all the notes that I'll be writing, I'll be sharing the digital copy of that. You can see that PDF right after the session ends, right? Yes, Ravi, that will be covered. Yes, yes. Yes, Vikhyat, sure. So we'll be starting with the session agenda and then the introductions. Yes, Shanti Nag Subramaniam is asking, I am 14 plus experience, will this help? Yes, DSA content will help everyone. So nothing to lose over here. Everything you will be learning. Yes, yes, Harpreet, that's a separate thing, right, Harpreet? So I'll tell you what we are going to cover in the next 2 months also. So do not worry. Okay. Fine. So we'll set the schedule and all the expectations of this 2 months of intermediate content. But first, let's start with the session. Okay. So let's get started now, everyone. So if you all can see this screen. So today we are going to learn, as the heading of the topic says, need for problem solving. So what we are going to learn today, we are going to learn problem solving. What is problem solving? What is the need? So we'll understand that need with the help of solving some simple and fun problems. So we'll have some simple and fun problems that we will solve in this class. A few problems that, if I mention, they are finding whether a number, checking whether a number is a prime or not, finding the square root of a number. These are two problems that we will do. They won't require that much of maths. You know, basic maths, then you will be able to do. We'll go from the basics. Okay. So this is the content structure. We'll start, since it's an introduction first session, it will start the main content by around 9:15. Okay. And once we start with this, we'll take at least 1 hour 45 minutes. Then we'll set the schedule for the next 2 months. And finally, we will take up your doubts. So this is the today's agenda. Does this agenda make sense? We'll also discuss some real world examples where you will need problem solving. So our today's focus is just to understand the need for problem solving. So what we are going to do in this intermediate module is problem solving. And today we will learn the need for problem solving. What are the key things? How you can think of problems yourself. So basics, will set up that basic agenda, right? Okay. So with that in mind, let's get started. I'll very quickly introduce about myself. So my name is Sahil Bansal. I have graduated from BTech CSE IIT Jammu. So I graduated from BTech CSE IIT Jammu. I have 2.5 years of teaching experience roughly. So I have taught DSA, object oriented programming, DBMS development. I have taught Django. So basically, in DBMS, OOPS also is something we will be covering, right, in this intermediate module. So nothing to worry about, right? And I used to conduct some workshops at my college. I used to take part in competitive programming contests. I went to ACM ICPC on-site regionals 3 years consecutively. And my team at college grabbed a rank of around 70 out of 3,000 teams in the online regionals. So that are few of my achievements. I have been a problem setter with CodeChef. So I have set a few competitive programming problems. So that's mostly about me and about my journey at Scalar. I started as a teaching assistant in April 2019 when Scalar just started. It was Interview Bit Academy at that time, and I am a software engineer and an instructor. So I also write code. I also develop features. So from June 2020 till now. So that's about me. And a few of my hobbies are meditating and doing yoga, and also I like watching Marvel series. So Thor is one of my favorite characters there. Yes. So Venkat, I am working at Scalar full time. So that's about me. If you all can also briefly mention one line about you, about your educational background and your two hobbies in the chat quickly, so that I can go through who all are in this batch. Just a very two-liner intro for everyone about your educational background, about your two hobbies. Okay, Saivas, great. Awesome. So everyone, if you could just give a very brief introduction in the chat, it would be really great. We all can know about each other. Okay, so Deepith is also interested in Marvel. Amazing, Deepith. Vishal says 5 years in TCS. Okay, Vishal. Hobbies are listening music. Nice, nice. Great, Harpreet. Everybody here definitely loves to code. You read books, that's great again. Gaurav, hobby is traveling, that's amazing. Chandan is a gamer. Okay. Venkat, that's amazing. You are already working as an AI engineer. That's wonderful. Narendra, Naveen, great, great. Diman, Dev, 1 year, Dev. Dev, are you outside of this universe? I think you meant 11 years, right? It must be a typo. Okay. Great, Ravi. Venkat. Swati says 3 years in SAP. Okay. Okay. Leo Joss. Western classical music and Japanese animes. Wow. Nikhil, Akshay. So I'll just read the names and quickly glance over and go through the names. Okay. Abbas Bansal. So we have one more Bansal. Abbas Bansal. Nice. MCU fan. So we share some interest as well. Okay. Pooja is doing masters currently. That's amazing. Aditya, awesome. Vamsi, Amit, Gajala, Manhoj. Manhoj. That's a good name, Manhoj. I hope we don't pronounce it as Manoj, right? We pronounce it as Manhoj. That's a good name. Jeff, Khwaja, awesome. Football. Hari Prakasham, Sai Siddharth, Praveen Bansal, Sai Yashwant, again a Marvel fan. Badminton, amazing. Deepthi Krishna, testing and okay, awesome. Novels, that's amazing. Ranita, CSE 2016, awesome. Anu, Shini, Venkat, Ram, Metal Rocks, that's amazing, Ram. Dhanush is again a Marvel fan. Wow. Jitin, you're from IIT Delhi. Wow, Jitin, that's great. And you teach physics presently and like to run. Amazing, Jitin. Nirav, you completed MBA currently in UK. That's amazing, Nirav. Mohammed, Rishabh, you are MTech IIT Jammu. Wow, Rishabh. Great. Nice. Chaitanya, VTech ECE, 6 years of overall experience, love traveling. That's amazing. Mohammed, amazing. Anand, Shika. Okay, we have few people who play badminton. Abdurab, Yogarajan, Rekha, 4+ years in analytics. Currently with Hotstar, amazing. Rohit, great. Shini, Aniket. So I think this list will go on. Jagrut, Sanat, Devdat, 11 years. Yes. Gaurav, Venu, Sunil. So I'll read through all your responses later on as well. Yes, Saivasu. Yes, Anshu. SMK, what's your full form of the name? Sunny, Rishabh, Abhishek, Chinmay, Sahil Jindal, currently teaching and love cricket. Wow. Yeah. Vikhyat, Shubhang. Awesome. So now we are done with this introductions. Let's get started. So we will start now, everyone, with today's content. So today's content is more about some simple and fun problems, right? And we'll take a look at some real world problems, real world examples. We'll set the expectations for the next 2 months of DSA content. So DSA content primarily will be divided into intermediate module and the advanced module. So one of the module happens before your DSML content. So 2 months of this module will be DSA, after which the DSML, the data science content starts. So I'll be teaching the DSA content, data structures and algorithms, for these 2 months, right? So let's get started, right? So I'll launch a simple quiz, everyone. So you will see a quiz in your screen. You have to answer that quiz. So let's start with the first problem and the first quiz I'll launch. Just give me 1 second. Okay. So we have 2 or 3 quizzes. Let's start. So our first problem will be, we'll be discussing a very simple problem. It doesn't require you much knowledge, right? Don't answer in the chat, everyone. Please select the option. For answering the quiz, you just have to select the option. Please do not type it in the chat, everyone. Great, Ravi. Great. Shanti. Nag Subramaniam. Shubhang. Great. So I'm just reading over some of the intros that were left over. Okay. Okay. Fine. So most of you got it correct. Okay. So the answer for this, Sai, Rishabh, and yeah, great. Matisha, you just joined. Nothing much we have discussed. We just went over the agenda and the introductions. So let's start now. We are just starting. We just launched our first quiz. So which of the following is a prime number? And the answer was 23. Now, most of you, since you got it correct, let me also ask a quiz. What exactly is a prime number? So there'll be a quiz. Please don't answer in the chat. Only answer in the chat when I ask you to do so. So in the quiz, you just have to select the option. So let me just launch one more simple quiz. So given a number, when can we say it is a prime number? Please just select the option. Okay. Okay, awesome. So most of you didn't get this correct. That was expected. So almost half of the class or most of the people answered it incorrectly. No issues. So let me just share my screen again and let's get started now. Fine. Okay. So what exactly is a prime number? So basically, if you see, a prime number is a number which has exactly two factors, right? So it's 1 and itself as the factors, right? If this is the definition that we consider, okay, so this won't hold true for what number? So if you say that if a number has 1 and itself as factors, yes, Swati says the exception was 1. Awesome. So if we consider this as a, let's go over all the options. So let me just check what other options were there. Just a moment. Number of factors are greater than equal to 2, 1 and itself, and equal to 2. So there were these three options. So if you see, if you all of you observe very carefully, this definition will not hold true for the number 2. Okay, sorry, for the number 1, because 1 is not a prime number, right? If you consider the number 1, this is not at all a prime number. The smallest prime number that we have is the number 2. Okay, so since we start with this smallest prime number as 2, this definition doesn't really work out for n is equal to 1. That's why we need to have a definition that is applicable to all the numbers, right? All the numbers where n is greater than equal to 1. In the problem itself, it was mentioned it should be greater than equal to 1. So if we have this definition where the count of factors is exactly 2. So what is a factor? A factor is a number that divides that given number. So for this number 6, if you write down the factors for the number 6, let's say we have this number 6, the factors are going to be 1, 2, 3, and 6. All of these numbers divide the number 6. So how many factors does this number have? Is 6 a prime number? Yes or no? The count of factors should be exactly equal to 2. Yes, it's not a prime number, right. Amazing. So since it has 4 factors, we need exactly 2 factors. Okay. So if you consider the numbers 1, it has factors, it has only 1 factor. That's why it's also not a prime. But if you consider the number 2, what are the factors of 2? The factors of 2 are 1 and 2. So if that is the case, okay, let me repeat why this doesn't hold true. So for the number 2, first of all, you have exactly 2 factors, 1 and 2. So it is a prime number, right? And then if you consider, let's say a number 3, if you consider 4, if you consider 5. So for these numbers, for the number 3, the factors are 1 and 3. For the number 4, the factors are 1, 2, and 4. For 5, 1 and 5. So out of these 3 numbers, what all are prime? Can all of you tell? Out of 3, 4, and 5, type in the private chat. In the 2 fields, select the name, select my name, and then type. Please do not answer in the common chat. Only questions have to be taken in the common chat. Okay. Yes, so 3 and 5 are the prime numbers. Awesome. Now, Matisha is asking why 1 and number itself as factors is not true because of 1, because of n is equal to 1. So, Matisha, if you see, this is an exception, right? In this case, it has 1 and the number itself as the factor, but it is not a prime. So that's why this quiz was there, so that most of you will get it wrong. Okay. Is this clear now? Awesome. So now what we'll have to do is, we'll solve this simple problem. Given a number n, you have to check if the input number n is a prime number. Okay, so Venu is saying, can you show the question and options again? Fine, so the options were, this was the first option, and the second option was count of factors should be greater than equal to 2. Third option was count of factors should be equal to 2. So there were these 3 options, right? Abhishek, 1 has only 1 factor, that is why it is not a prime. Okay. 2 is a prime, 3 is a prime, 5 is a prime, 4 is not a prime. So I am circling the ones which are not primes by red and by green which are primes. So 1, 6 and 4 are not primes. Okay. So this option, count of factors equal to 2. This was the correct option. So till now, all clear? All clear, yes or no? Okay, so let's solve our first coding problem. So we are given a number n, we have to check if the number n, if the input n is a prime number or not. So we have to write an algorithm. So we have to write an algorithm to solve this very simple problem. Given a number n, check whether it is a prime number or not. So you have to basically count the number of factors from the range 1 to n, because the maximum factor that a number will have will never exceed n, right? So you just count the number of factors from 1 to n. If that comes out to be 2, that means the number is a prime. So all of you take a pen and paper, try to write the pseudocode for this, try to complete this function. Def is prime of n. Take 2 minutes, everyone. Try to think of it. Yes, Sini, please write the code or the pseudocode in your pen and paper. Do not need to share here. That's okay. Siddhika Pawar has raised hand. Do you have any questions? If you have questions, please ask in the questions tab. Okay. Abhishek says done. So how many of you have written this pseudocode? Can you react with a thumbs up? Okay. Harpreet and Ram have already sent it in the chat. That's amazing. Awesome. Okay, so let's continue. Let's try to write it down and then see that what is the issue with this code or what can we do better. So whenever we will solve a problem now, we'll have two types of solutions. One will be the brute force solution. Okay, so we'll have two types of solutions. One will be the brute force or the most simplest solution that you can come up with, and then we will see how can we optimize this code. Okay, so let's start with this first solution, first code, pseudocode. Okay, so this is the function that we are trying to implement. We'll have a count. We'll maintain a count of factors. So we'll say count is 0 initially, and then we'll write a loop. So if you see, let's say if you want to check whether 15 is a prime or not. So what you will do, you will start with the number 1. Is 1 a factor? Is 1 a factor? How will you check? You will check that whether dividing 15 by 1 gives a remainder of 0 or not. So we have to simply check 15 modulo 1, it will be 0. What will be 15 modulo 2? It will be 1. 15 modulo 3, it will be 0. So whenever the remainder is 0, when we divide a number by another number and the remainder is 0, that means it's a factor, right? 3 is a factor of 15. So that's how we are going to check. So we'll simply iterate from 1 till what number? All of you tell what number we will iterate. We'll write a loop till 15. Yes, Avjit. Yes, Rohit, Chinis, absolutely. Chandan, n by 2. Okay, Chandan, let's think of the simplest solution that we have, right? Aditya, you all are going a bit ahead. Those who are saying square root n, you are also going a bit ahead. Let's stick to n for the time being. That is 15. So we'll simply keep checking, and whenever it is 0, what we will do? We will update the count, right? Whenever it is 0, we'll increase the count. So let's have a loop. All of you know how to write a loop, right? So we'll have a loop from I is equal to, if you see in Python, the comments are by hash. So let's say we'll have a I variable that will go from 1 to n. So how can we write it in code, in pseudocode, Python like pseudocode? We'll say for I in range from 1 to n plus 1, right? And once we say that, then we'll simply have to check if the number n is divisible, n modulo I is equal to 0, Then we are going to increase the count, right? We'll say count plus equals 1. And at the end, we'll simply check. We are simply going to check at the end. If the count is equal to 2, that means the number is a prime number, right? So in this case, we can simply return true. Otherwise, we are going to return false, right? Does this code make sense to everyone? Okay, Shubhi is asking, why are we going till n plus 1? First of all, great. Please ask questions in this format only, like Shubhi has just asked. So that way, when I click answer now, it will show that your question is being answered, right? So that's the best way to ask questions in the class, not by asking it in the chat, because that clutters the chat, right? And questions get lost. So we are going till n plus 1 because the syntax range keyword, it excludes the last index. It excludes the last element. So when we talk about a range of 1 to 3, it is nothing but it includes only the numbers 1 and 2. When we talk about range of 1 to 4, it is going to include 1, 2 and 3, right? So the last number, if you see this last number, it is excluded. Okay. So that is the idea behind why we have n plus 1, because we want to check from 1 to n, right? Is it clear? Vishal, Shubhi, is it clear? Yes, Matisha, we can do that. Absolutely. We can definitely do that. Can't we use n mod I and count? Yes, Vishal, we can use that. Absolutely correct, Vishal. Why do we have to check count at the end? Yes. All of you are asking the same question. So the answer is you can break earlier. So, but still, let's just go with this solution for now. Now, my question to all of you is that how much time will this program take, right? Anshu is asking why till 15? Because the number of factors, Anshu, it won't exceed n. If n is the number, the last factor it can be is n. Any number greater than n won't divide that number, right? Right, Anshu? Okay, awesome. So most of you are answering. It's going to take order and time. So till now we have not discussed what big O is. We are going to discuss what is big O in the next two sessions. Okay. So okay, still some of you know that, but let's figure it out quantitatively. Let's take a value of n and try to figure out how much time it might take, right? Is it the index we are using in for loop? Aniket, no, it's the range. So if you see range of 1 comma n plus 1 will iterate over the numbers from 1 to n. It is same as saying for I is equal to 0, I is equal to 1, I is less than equal to n, I plus plus. If you come from a programming language like C plus plus or Java background, then this is the kind of syntax it might look like, right, Aniket? It's the same thing. Yes, Sanath has given a very precise answer. Time taken to loop through all the numbers from 1 to n. So let me just ask you another simple quiz. All of you, just let's take one more quiz. Okay, so please answer this quiz, all of you. This will help you clear a lot of confusions that you're going to have, and it's going to help us answer the time part. Yes, Venu, your question is already answered by Aditya. You can't use 0 because anything divided by 0 is going to give you runtime error. Okay, so Akshay, in this question, it's included. We are asking from 2 to 10, right? Awesome. So if we see the numbers from 2 to 10, let's just write them down. So if you see, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly 9 numbers. So if I ask you what are the numbers in the range A to B, where both A and B are included. So square brackets would mean both are included. So then they are going to be how much? So if you see from 2 to 10, it is going to be 10 minus 2 plus 1, right? 8 plus 1, that is 9. Yes, all of you are correct. Jiten, Sini, it's going to be B minus A plus 1. Okay. And if I ask you what is the numbers that will be from A to B, where B is not included. So if B is not included, what will it be? It will be B minus A, because this plus 1 won't come there, right? Awesome. So what is range of 1 comma n plus 1? If you see what is range of 1 comma n plus 1, it is nothing but 1 comma n plus 1, where n plus 1 is not included. So how many numbers will be included in this loop? Like how many times will this loop run? The number of times this loop is going to run will determine the time taken by this program. Yes or no? Yes or no? Right? The number of times this loop is going to run. So that's why we are going to figure out what is the exact count of this loop being run, right? So from 1 to n plus 1, where last number is not included, it's excluded. Okay, so this B is here excluded. So it's going to be n plus 1 minus 1, and that you see it comes out to be n. So this loop is going to run n times. So we have figured out this loop is going to run n times, right? So basically, if we know in 1 second how many times the code can run or how many iterations can be performed by your processor, by your computer. So let's have one assumption. So I'll just write it down. So let's take this assumption that there are 10 power 8 iterations that can run in 1 second. So in your program, if I say what if n is 10 power 9? So if n is 10 power 9, what's going to happen? There will be 10 power 9 iterations. Does that make sense? So you are going to have exactly n iterations, n times this loop is going to run. So this loop is going to decide the runtime of your program. Yes, because rest all these statements, they are just single statements. They can take, let's say, 1 unit of time, constant unit, but this loop will vary depending on the input size. Okay. So don't worry, we'll discuss about time complexity in the next 2 sessions in depth. But for now, let's figure on the number of iterations. Let's figure out on the number of iterations. If n is 10 power 9, there will be 10 power 9 iterations. And if 10 power 8 iterations take 1 second, how many seconds will be taken by 10 power 9? Can you all figure out that maths? In 10 power 9 iterations, how many seconds will it take for the program? Yes, all of you have answered 10 seconds. Swati, not 1, because 1 is for 10 power 8. If you just go back to your school maths, so you'll just say for 10 power 8 it is 1. So for one iteration it is 1 divided by 10 power 8, and for 10 power 9 it is 1 by this into 10 power 9. That's exactly 10. So you are going to take 10 number of seconds, 10 seconds to kind of execute this program. Let's say if we have a larger number, okay. So when we'll talk about data is going to be huge, right? So the large number you have, let's say of order 10 power 18. So then your time taken will come out to be roughly 10 power 10 seconds. Yes, you will get TLE, right, Narendra? Absolutely. So if you go by this formula, a power m by n, right? So a power m by a power n is this. So we are just using that. So it will be 10 power 18 minus 8, which is 10 power 10 seconds. Now, all of you, if you just check the value of 10 power 10, It's huge. It's huge. This much seconds would mean that if you convert it to hours, days, and years, it's gonna take 300, roughly 317 years. Is this a good program? Is this a good algorithm? We have to think how to optimize. So okay, let's first recap it a bit. Do not worry, Matisha. TLE is something you will see when you solve today's assignment. We'll talk about that later. Gajala, yes, we shall forget about that for a moment. Uh, yes, Gajala Deepti, can you explain? So, which part exactly? Assumption part. Okay. So, we are assuming that these many iterations will happen in 1 second. If you have a loop that runs for 10 power 8 times, if you have a loop that runs for 10 power 8 times, that will take 1 second. So, this is one assumption that we have made. Just don't worry about it. We'll talk a lot in time complexity session. For now, we are just giving you a basic overview of how to optimize this algorithm. So we are coming to that mainly. Should we forget about that for a while? Okay. Yes, Shubhang, you will see that in today's assignment. So those who do not know about the term TLE, it's not DLE, it's TLE, Shubhi. So you will see that in today's assignment. For sure, you will see that in today's assignment. Rohit, because an n value, the input n can be 10 power 18, right? The input n can be very huge. So your loop is gonna run 10 power 18 times, right? We just figured this out that Rohit, this loop will take that much amount of time. Yes? Yes, yes. Yes, Narendra. Is that clear, Rohit? Because this loop runs from 1 to n. Even if we break it when count is more than 2, but still for a prime number, you won't be able to break it. It will break only at the number n, right? It will start from 1, at n it will find the second factor, and then this loop will break. So in the worst case, again, don't worry, let's focus now on how to optimize. So for now, just take this. It will take a lot of time. We'll have a separate session on time complexity, right? Now let's try to figure out what can we do to optimize. What can we do to optimize this? Any ideas that you have? Vishal, I did not get your question. How come just 2 digits? So Vishal, this is in terms of seconds, right? Even if it is n by 2, some of you are saying n by 2. Okay. Awesome. Aniket says right. Okay. Mohammed. So I see some of you are coming to the idea. That's great. That's great. So I'll let you all think for 2 more minutes. Venkat is saying by recursion. Venkat, we do not even know what that is. Ahan, we are discussing about how to check whether a number is prime, and we have written a very basic algorithm. We are trying to optimize that now. Yes, Rohit, some of you are getting to the idea. Some of you might have solved it before. So that's okay, but we will see how to build on the idea. Okay. So I'll have one simple quiz for all of you. This quiz is going to help us in this problem. So can all of you tell me, if A is going to be less than equal to 57, what is going to be the maximum value of the number A? It's a very simple quiz. Please don't answer it incorrectly. Okay, so most of you understood this. Yes. We are coming to that, Shanti. Do not worry. Let's come to everything and let's focus on how do we optimize this. Okay. So now the point is we have let's say that we have a number 16. Let us write its factors. So the factors are 1, 2, 4, and then after 4 there's going to be 8 and then 16. So we have these 5 factors for the number 16. It's not a prime. Definitely it's not a prime. All of you focus here now. If you have anything else going on, please close it. Focus here. We are seeing how we are coming to the optimization. Okay. So we have these factors for the number 16. Now, can you observe anything from here? Can you see that if we take the first number and last number, if we multiply them, we are going to get 16. If we take the second number and second last number, we multiply them, 2 into 8, we are going to get 16. If we take this number and we just multiply it with itself, we are going to get 16. Let's take one more number and see whether this observation we are going to get. Okay. So what we are trying to figure out is we are just trying to make some observations and see if these observations can help us. Okay. Let's take one more number. N is equal to 24. So I have already written down the 8 factors of 24. So if you will see, 1 into 24 is going to be 24. 2 into 12 is going to be 24. 3 into 8 is going to be 24. 4 into 6 is going to be 24. And then if you will see what happens after this point, let me very quickly write it for all of you. Right. So given a number, can you see that these after this point, all of these numbers, they start repeating, right? And for these 4 numbers, you are able to find these 4 numbers as well on the right side. So basically, if you just know the first half, if you just iterate over this point, is there any need to check in the second half? Is there any need to check in the second half? If from the first half itself you are going to get the second half, there's no need, right? Let me repeat it. I know some of you have some questions at this point. So I'll repeat it step by step once again in a different manner. Let's say that one number is a factor that is A, other number is B. Can I say that if both of these numbers are factors and given that A into B is N, given that A into B is N, from here can I say that both A and B are going to be the factors? Right, because both of them are going to divide the number N. Yes, that's for sure correct. So if we know A, if we know A, if we know the first number, can we find out what this number is going to be? Can we find out what the other number is going to be? Yes, how? Why not? We already know their product is N. So can I simply say B is going to be N by A? Let's say if A is given to us, then B we can find out, right? Yes, B is going to be N by A. If you see, this number is 24 by 1. This number is 24 by 2. This is 24 by 3. This is 24 by 6. And now, once you have these 4 numbers and their pairs, so you see that you have got 4 pairs. By using these 4 pairs, you are able to figure out, if you see, using these 4 pairs, you are able to figure out all the 8 factors, right? Because what essentially is happening is these factors, they are coming in terms of pairs. So this is the key idea, that these factors, they are appearing in pairs. Okay, I'll write it down, do not worry. Now let's just take one more example so that it becomes clear, right? Okay, Sunil, let's see for 100. Sunil, let's see for 100, you will get the idea. For 100, let's start from 1. If 1 is a factor, Sunil, 100 by 1 will also be a factor, because if A is a factor given to us, we know how to figure out B. B is going to be n by A, right? So we can say that if 2 is a factor, 100 by 2 will be a factor. 4 is a factor, 100 by 4 will be a factor. 5, then 100 by 5. Okay. 10, so 100 by 10. Then 20, so 100 by 20. 25, 100 by 25. 50, 100 by 50. 100, 100 by 100. So if you see these numbers, if you just write these numbers, then you don't even need to go further. You don't even need to go further. This is not needed. You can stop your loop. So what we are trying to do is we are trying to reduce the number of iterations of our for loop, right? If we can somehow bring down the iterations, because for 10 power 18, these number of times the loop is running, which is very bad for our efficiency, for our time of the algorithm. Okay. Is it clear? Is it clear to everyone till this point that these factors, they are coming in pairs? So when we have one factor, we can find out the other factor. Okay. Now, if we say this is A and this is B, so from A we are getting B. Okay. In the first half, can you all see that the first number, that is A, is smaller than equal to B in this part 1? So we have two parts. If we iterate through the part 1, we do not need to go through part 2. In part 1, A is less than equal to B. Can all of you see that? In part 1, the first number is always going to be less than equal to the second number, right? And in part 2, if you write down the part 2, here what will happen is the second number will be larger, and that number we already have seen earlier. So there's no point going further. Okay. So uh, let's write down our observations and come back if you have any questions. So the observations are basically, the first observation is if we iterate on part 1, we can get all the factors of n. Do you all agree with this now? In the first part, if you just iterate, you will get all the factors, because from A you can get the value of B, right? So the main observation was factors come in pairs, and when this number n has some special property, then there'll be one such factor. If you can see, there'll be one such factor where both these terms, A and B, both these terms are going to be equal. So these pairs are nothing but A comma B, and A is less than equal to B. So what will be the maximum value of A? What will be the maximum value of A for which this will hold true? So if you see that, the maximum value of A will be, if you just write that A into B is n. Okay. If you see, A into B is equal to n. And we also need to make sure that A has to be less than equal to B. So we need to figure out what's going to be the largest value. So what can be the maximum value? Can we say that it will be B? If we try for B, if we try for B, I just asked you a quiz. A is less than equal to 57. What is the max value of A? It is 57, right? So here the max can be B. So that means if the max value of A is equal to B, then we will have A into B, which is A square is equal to N. That implies A will come out to be square root N. Take square root both sides. So you will see that the max such value, okay, will be square root of N. So here, as you can see, in 100, this is square root of 100. Okay, let me just repeat this part. I know it's little bit slight maths. So let's first write down the observations. Let's first write down the observations and then I'll repeat this part. Okay, just give me one moment. Yeah, good question. Okay, so till now what I just said, wait, I just added a new page in the wrong place. Okay, so Anu, let me just repeat this. If you still anyone has any questions, do ask. So we are going a little slow. Please do not worry, because we are just trying to understand how we are coming to the observations. Okay. So the first thing we observed was that these factors are coming in pairs where A into B is going to be equal to N. And if we divide it into two parts such that the first part has A less than equal to B. Okay. If we divide into two parts, one where A is less than equal to B, one where A is greater than B, then we need not iterate over the second part. Fine. Now, how do we find out? How do we find out what is the range? What is this range for the first part? How do we figure this range? So that's where we are trying to find out what can be the maximum value where you can stop. So what can be this maximum value where you can stop? Okay. So let's see for 24 and 100. So we need to figure out max value for part 1 A, right? So for that, we know that A is going to be less than equal to B. So if A is less than equal to 57, what can be the max A? It can be 57, right? So here, what can be the max A? It can be B, right? And we know that, right, it can be B because A is less than equal to B. And we know that their product has to be equal to N. So A into A is equal to N. Can I say that we can replace B by A because B and A are the same? So A into A is N. Now if we take square root both sides, so what is it that you all will get? You will get A is equal to nothing but square root of N. So that's how you got this largest value. Now let's try to see for N is equal to 24. What is square root of 24? It will be something around 4.9 something. So we will just take since we are just iterating over integers, we'll get 4 point something. So we'll take 4, right? We'll take the integer value. And if we go for 100, we figure out the square root of 100 is 10. So basically we'll just need to iterate over 10. So till now we have made these observations. That first observation, if we iterate on part 1, we can get all the factors. Now in part 1, what's the minimum value of I? The minimum value of I is 1. In the part 1, the maximum value of I is square root of N. So till now we have made these 3 observations. Now using these 3 observations, can we optimize the solution? Can we optimize the first code that we wrote? All of you think about it now. Yes, Aniket. Yes, Dev. Awesome, Ravi. Manhoj, correct. Yes, Aviji. There is no need to check in the second half. That's what we arrived at. Okay. So the key idea is now we just need to focus on this first part. Okay. This part one that we have over here. We just need to focus on this part, right? Okay. Yes, Demon, absolutely. So let's we observed these things, we wrote down these observations, and now let's focus on the original problem. So the original problem was that we had to count from 1 to n. There should be exactly how many factors? Two factors, right? So if from 1 to n there are going to be two factors, from 1 to root n, how many factors will be there? From 1 to root n, we need one factor, right? If there is all, if there is going to be 1 to root n, one factor, because n is always a factor, right? Now from 2 to root n, if we just ignore 1 also, because 1 is also going to be a factor, right? So then from 2 to root n, how many factors should be there? There should be 0 factors from 2 to square root of n. There should be no factor in this range. If there is no such factor in this range, then we can say that the number n is a prime number. Okay. So what we started with, these observations helped us reduce the problem. So this is the idea of how we get to the observations and try to use them to break our problem into a different problem that will be much more optimal. Okay. Now let's just see for an example, n is equal to 23. The square root of n is 4. Okay. If we have I, and let's try to write down the n by I value on the right hand side, because for a we wanted to get the n by a, right? That's the other part of the pair. So we have 1, the other part is 23. Okay. So we already know that 1 and n, they are going to be the factors. So we do not start from 1. We do not start a loop from 1. We'll start from 2. We'll start from 2. Here 1 and n are already two factors. So we'll already have got two factors over here. So now there should be no other factor in the remaining range. So what we will simply check is, we'll check whether there are 0 factors from 2 to root n. So if you will see 2, 3, 4, all of these numbers will not divide, 23, will not be a factor. So earlier you were iterating for 23 times. Now you are going to iterate how many times? Can you all tell me? For 23, how many iterations? Yes, Anu. Yes, Nirav, Manhoj, Leo, Arik, Prakash. Awesome. It's going to be just 3 iterations. Because you are just ignoring this rest of the half, which is of no use to us. Okay. Perfect. If this makes sense, then let's try to write the updated pseudocode. I already have written it just to save some time. So we'll have this function. Now it's going to go from 2 to root n. The value of I will go from 2 to square root of n. Okay. Okay. Abhishek is asking how it should be 3. Fine, Abhishek. So see, Abhishek, we will go from 2 to square root of n. And here square root of n is 4 in this case. So if we have the range 2 to 4, how many numbers are coming in this where both are included? Abhishek, it is 3 numbers, right? We just have to check whether there is 0 factor. So no number should divide in this range 2 to square root of n. Fine. Okay, so let's see the code and then it will be much clear. So now you have something like this. You will go from 2 to square root of n plus 1, and then you will check if n modulo I equals to 0. That means if I divides n, then count will be increased, right? Or else if this happens, we can simply return false. Here itself we can return false. Why? Because we want no factor should come in this range. There should be no factor in this range. Fine. So if the count comes out to be 0 at the end, we can simply return true. Or else we can get rid of this count. This count is not at all required because we can just check it inside this loop as well, right? Okay, now somebody is saying that there's an edge case. So what's an edge case, Shubhang? Praveen says it will give error for perfect square. Are you sure, Praveen? Think about it, Praveen. All of you got it correct that n is equal to 1 is a corner case here. So we have figured that n is equal to 1 will fail. Why this is going to fail is if you just go a little below, you see that count is 0 here. Let's figure out for n is equal to 1 what happens. So count is 0. Will 1 ever go inside the loop? So for 1 the range is from 2 to 2. So what is range of 2 comma 2? Range of 2 comma 2 is nothing but empty set. It's nothing but empty set because the last number is not included, right? So range of 2 comma 2 is just empty. So we'll not go inside the loop for n is equal to 1. Count is already 0. So we are going to return true, right? But 1, is it a prime? No, 1 is not a prime. So we should return false in this case. So basically, we have to handle n is equal to 1 edge case. So these cases that break, these cases that need to be critically handled, these are the edge cases, right? Himanshu, let's assume that this is an integer. Let's assume that we convert it to an integer. So all of you, if any of your questions is not answered, please keep it in the questions tab. I'll answer the questions as and when we'll get time, right? At the end, we'll have separate doubt session as well. So do not worry if something gets missed. In the chat, a lot of chat comes. So some chat might get missed. That's why I request to put it in the questions tab. Okay, so we just need to handle this case like this. If n is equal to 1, we will simply return false. Okay. And we do not even need to maintain the count because whenever we are going to get a number that is divisible in this range by the number I, we will simply we'll simply say that it's not a prime and we will break, right? So this is the optimized version of the code. For n is equal to 2, it's going to work. For n is equal to 3, it's going to work. For 4, it will be not a prime. So just try it out, everyone. You will figure out that it will work perfectly. Hari Prakasham, an edge case is nothing but a case where we haven't considered it very well when we were thinking about the solution. Okay. So one is a boundary case or an edge case. At the extreme values of n. N is 1. N is 1 is an extreme, right? It's just the start of the range. Okay. Awesome. Yes. Yes, Abhishek. Sometimes we can. Fine. So now you all have this. Can you tell me how many iterations will be there? If you all have got the idea, can you all tell me how many iterations are there for this program? How many times the loop will run? Okay. Yes, we shall. Let me explain 23 case. Awesome. So we shall see what will happen for n is equal to 23. What is square root of n? It is going to be 4 point something, 4.9 something. And we will take the square root, we'll convert it to an integer. So what's the integer value? It's going to be 4. Okay. So what is the range of 2 comma 4 plus 1? That is 5. It is nothing but 2, 3, 4. Right. The last number is not included. Sorry. So you will iterate over these three numbers, 2, 3 and 4. You will check, Vishal, whether 2 divides 23, no. 3 divides 23, no. 4 divides 23, no. So we will say that it is already a prime. We are going to set prime equal to true earlier, and we need no factors should be there in this range. So we didn't get any factors. So we'll simply return prime, that is true, right? Does that make sense, Vishal? Just try to do a dry run. Try to go through this code step by step with this example. So you will see that 23 is going to be a prime, right? So if I go back, it should not have any factors in this range 2, 3, 4. And it doesn't have, right? It should not have any factor in this range, and it doesn't have. Based on the observations, we figured this out, right? Based on these three observations, we figured this out. So I hope it is clear. Awesome. Yes, n is equal to 2 case also, Venu, it's very similar. Okay, yes, let me do a dry run for n is equal to 2 as well. So what happens for n is equal to 2? If you will see that, let's do for 2 and 3 as well. Okay. For 2, the square root of 2 is going to be something like 1 point something, right? It will be 1 point something. And if you see that, if you add to 1, it will be 2 point something, and you are just going to take the integer part. So you'll have range of 2 comma 2. Is there anything to check in this range? No, it's an empty range. So will you ever go inside the loop? No. So your prime is set to true. You will return true. You are not going inside the loop. It won't become false, right? So you are simply going to return true. So n is equal to 2, it works. Similarly, for n is equal to 3, if you will try, square root of 3 will be, again, it's going to be 1 point something. And the range will be empty. So you will not go inside and it will return true. So this is also going to work. Now for n is equal to 4, if you try, it's not going to be a perfect, not going to be a prime number, because square root of 4 is 2. So your range will be 2 comma 3. This comes out to be 2. If you see in this range, the number 2 divides 4. So you will set prime false and you will break. Does that make sense? So for n is equal to 4, you will go inside this loop, right? Your n value 4 modulo 2 will come out to be 0. And you will set prime false and you will break, and you will return prime which is false. So 4 is not a prime. So all these cases 1, 2, 3, 4, are they clear? So for a perfect square also it will work perfectly. So 4 is a perfect square, right? Awesome. So all of you, now let's figure out the time taken, the number of iterations. So from 2 to square root n, if you see how many iterations are going to be there, there are going to be square root n minus 2 plus 1, which is square root n minus 1 iterations, roughly. Okay. So we didn't consider the last one. So we can also say it like this. So the last number is not included. So it's root n minus 1. Can we say it's roughly root n? Let's just ignore the -1 for now to make things simpler. Now let's go back at our iterations, go back at our time taken in seconds. So for 10 power 8, if it was taking 10 power 8 1 seconds, right? For 10 power 10, what time will it take? The iterations will be square root of 10 power 10, and we know that square root of a is a power half. So it's going to take 10 power 10 by 2, which is 10 power 5. So it's going to take roughly 1 millisecond. You divide it by 10 8, it's roughly 1 milliseconds. And for 10 18, 10 power 18, that was the case where you all freaked out a little. It was taking 300 plus years. So it's gonna take 10 power 9 uh, iterations, because iterations are square root of n. So you see how significantly we have improved the complexity. Now it's going to take just 10 seconds, 10 power 9 by 10 power 8, which is just 10 seconds. Earlier, a program which was taking 300 plus years, now it's taking only 10 seconds. Can you see the level of optimization that you have done? Did you all understand this? Are you all clear? Why do we need problem solving? So by seeing this problem, what is it that you understand? What is important to solve problems? What is important to optimize problems? So what were the three things that we wrote down? These three observations, yes, Abdurrahman. These three observations, they were the key to optimizing this problem. So yes, so the key to solve these problems is problems. So key to problem solving is observations. Let me write it down. And how do you use those observations? So the more appropriately you figure those observations out, you use them in a constructive way, then you will get the final solution, which is going to be a very good solution. As you can see here, it just takes 10 seconds for a huge number to check whether it is prime or not. And where it is useful, don't even ask me. Prime numbers are used at a lot of places. You have to check whether number is prime or not. It's used in cryptography. It's used in, you won't be able to do a transaction online if there were no prime numbers. So all the online encryption algorithms like RSA, etc. Not sure if RSA, I don't remember too much now, but there are a lot of encryption algorithms. Crypto world has a huge usage of prime numbers, right? Okay. So now with that, let's take a little bit of break. Let's take 5 minutes break, and then we are going to solve one more interesting problem. Two small problems and one more interesting problem. So today's session will go on till 11:30. We'll try to finish by 11:30. 5 minutes break, all of you. Take some water and come back. If you have any questions, just post them in the questions tab if anything is not clear. I'll repeat it in the doubt session as well. Awesome. So I hope all of you are back. Shall we get started again? Please give a quick thumbs up if you are back. Naveen, which question exactly are you talking about? Okay, Vishal and Gadiraju Venkat Nag Pavan Teja Tiwari. And what name do you have? Gadiraju Venkat Nag Pavan Teja Tiwari. One, two. It's the biggest name I have seen till now. I don't know any other person who has this big name. Abhishek, I'll answer your question. Okay. Shubhang, thanks. I'll also add bookmarks at the end of the session. So the bookmarks will be available if you want to recap any part of the session. The bookmarks and the lecture notes, both of them will be available. Okay. Let's get going again. Awesome. So I'll share my screen and let's start with the second question. It's going to take only 3 minutes. 3 minutes problem. We'll do 2 3 minutes problems. Very simple problems. So you are given n numbers, you have to find their sum. Let's say you have to find the sum of first 100 natural numbers. So it has a very clean formula. Do not type it in the public chat. Any answers in the public chat, I won't tolerate. I'll launch a quiz for this. So this was discovered by Gauss, and I'll tell you this story. And first, let me ask this quiz. So all of you answer this quiz. So what is the sum of first n natural numbers? Let's see how many of you know this already. Awesome. So most of you have heard of this formula, but today we are going to derive it. We are going to understand how did someone even come up with this. Okay. Fine. Let's start. So let's take n is equal to 100. So you have to find sum of first n natural numbers. Let's take n is equal to 100. So there was a famous person. He was Gauss. One day he was just solving this problem. What he did, he just reversed these numbers. He had to find some of these n numbers from 1 to 100. He reversed them. He wrote them in the reversed way. And then he added them one by one. Okay. So if you just add them one by one, you are going to get 2s is equal to, you add them like correspondingly, you will add them. So what is it that you're going to get? Every number that you will get here will be 101. And how many such numbers are going to be? There are going to be exactly 100 such numbers, right? Yes, n such numbers. So if you see 2s is going to be 101 into 100. So from here you can say s is. So very easily you can say that the sum of first 100 numbers is 5050. So isn't it amazing? Just by observing that you write the numbers in reverse way, add them column wise correspondingly, you are going to get each sum to be the same, and from there you can find out what's the sum of the first and natural numbers. So this is why observations are so important. If you just write it for n numbers, you will see that 2s is n plus 1. You're going to add n plus 1 n times. So you will simply get s is equal to n plus 1 into n. So since this is being added n times, right? Sorry. So you will get this final result, right? So this is something we are going to use a lot in our intermediate module when we'll talk about subarrays, when we'll talk about in maths also, probably in a later part of the course you might use this, but yeah, this is going to be very useful formula for us. So from now you will never forget this, right? If you want to derive it, you can simply derive it, right? Okay, so shall we have one more simple problem before we jump to a larger problem? So given a number n, count how many times we need to divide that number by 2 to make it 1. So when we will talk about divide by 2, we will only consider the integer division. So when we will say 15 by 2, we will use the double slash. In Python, double slash denotes integer division. So this is going to be, is it going to be 7.5 or 7? Type in private chat. 15 by 2, it will be 7. Yes, all of you are correct. We'll take it to be 7. Absolutely correct. So let's go, let's take some examples. I'll have some quizzes, all of you. So please answer this quiz. How many times do we need to divide 8 by 2 so that it reduces to 1? How many times exactly are we going to do this division? Awesome. Amazing. All of you, 76%. That's very good. Okay. So for 8, let's see the process. For 2, you just divide it once. For 2, if you just divide it by 2, you are going to get 1. So the number of steps for 2 is just 1. For 3, if you divide it once, you are going to get 3 by 2, which is 1 again. So it's also one step. For 4, if you see, you'll first divide it, it will become 2. And then you'll divide it, it will become 1. So here you have used up 2 steps. Now let's see for 8. Yes, Pooja, it will be 3. Correct. So 8 will divide, it will become 4. And then from 4, it's going to become 2, and then it will finally become 1. So you see that you will need 3 steps over here. Now for 15, 16, let's launch few more quizzes. So what will be the value for 15? All of you, 15. Please select the options. Please do not give the answer in the chat. Please select the options. Yes, Bipul, correct. How will you do that? Okay, this time it's less. All of you, what are you doing wrong? See, 15, if you divide it once, you are going to get 8. No, you are going to get 7. Then from 7, you divide 7 by 2 is 3 point something, so you'll get 3. 3 by 2 is 1. So it took 3 steps here as well. Took 3 steps, right? For 16, if you will see, it will be 16 will first get to 8, 4, and then 2, and then finally 1. So here you will have 4 steps. Okay. For 23, all of you, try for 23. I'll launch a quiz. Try for 23. How many times you need to divide it by 2? Har, Harpreet, think again. Manhoj, think again. Some of you are saying square root of n. That's incorrect. Think again. Okay. So let's continue. So basically, yeah, for 23 also it's 4. If you see 23 by 2, it will be 12, then 6, then 3. Sorry, 23 by 2 will be 11, not 12, it will be 11. 5, then 3, then 1. Okay, so it's going to be 4 steps again. For 64, if you will see, let's launch one final quiz. Let's see how many of you get it correct. One final quiz. I want all of you to be correct. Okay, Avijit, Shubhi, Himanshu, awesome, awesome. You people are doing great. 9 on 9. Fine. So here you see that there will be 6 steps because 64 by 2 is 32. 32 by 2 is 16. 16 by 2 is 8. 8 by 2 is 4. 4 by 2 is 2. And finally, you get 1. You see, this is 1 step, 2 steps, 3, 4, 5, and 6. You get total 6 number of steps. Okay. Now, what exactly it is? So if you see first of all, if you will see that in these cases, 2, 4, 8, 16, and 64, there's something special over here, right? What's the special thing? These are nothing but powers of 2. If you will see, this is 2 power 1. This is 2 power 2. This is 2 power 3. This is 2 power 4. This is 2 power 6. And if you can observe, their power is nothing but the answer. Can you see that? If a number is 2 power n, it will take n steps because at every step the power will reduce by 1. Every step the power will reduce by 1. We need to make it to 1. 1 means 2 power 0. Okay. Does that make sense to all of you? So if we have a number 2 power n, in one step it will become 2 power n minus 1. Next step 2 power n minus 2, n minus 3. And till where we need to go? We need to go till 2 power 0. So let us say that this is k steps. Okay. So this is k steps. This is 1 step. This is 2 steps. 3 steps. So after 3 steps you get n minus 3. So if you want 2 power 0. So let's assume that this is n minus k. And we say that k steps. So what it will turn out that n minus k is 0. That means k is n. So how many steps have you taken? N steps, right? So 2 power 2 is there, so it will become 1 and then 0. So it takes 2 steps. If 2 power 3 is there, it takes 3 steps, right? Does that make sense? To each and every one. Is this clear to each and every one? Why for 2 power n we will have n steps? Okay, Dhiman, let me repeat. See, when we divide a number by 2, let's say we have 2 power 4 is equal to 16. If we divide it by 2, we are going to get 8. What is 8? 16 by 2 is 8, which is 2 power 3, right? Because when we see 2 power n by 2, it is nothing but 2 power n minus 1. Every time the power will get halved. Sorry, not halved. Every time power will get reduced by 1. Now if you see, if you divide it by 2, you are going to get 2 power 2, which is 4, right? Divided by 2, you are going to get 2 power 1, which is 2. Divided by 2, you are going to get 1, which is finally 2 power 0. Okay. So you will have exactly n number of steps where n is the power. Does that make sense now, Dhiman? So every time at every step the power gets reduced to 1. So it's like you have a number that keeps reducing by 1. So how many steps you will make it 0? So if you have 4, 3, 2, 1, 0. How many steps is it taking you? It is taking you 1, 2, 3 and 4 steps. So from n to 0, it will take you n steps, right? Awesome. Now, if this is clear to everyone, then what happens for the other numbers? Sorry, my bad. I think. Okay. Yes. So what happens for the other numbers? We figured out that for these numbers, it is the power. And how can we find this power? Now, so main point is how do we find this power? For this, there is a fundamental concept of logarithms. So I'll share a reading material in the external references. So you'll have to read about this log. So what it simply says is if a number x is a power n, then log to the base a of x is n. And that helps us come to this formula that log to the base 2 power n is nothing but n. Okay. Log to the base a power n is n. So what is the power that we need to raise to get the number n? So what is the power that we need to raise for a to get the number x? So it is n. So it's inverse of power. Read about it a little bit. It will be very much helpful to everyone since it's also used a lot in data science field as well. I'm not an expert there, but I know some basics. So yeah, just read. It will be there in the extra references. For now, you just have to remember this formula that log to the base 2 power n is n. Okay. So now if you simply take the log, you are going to get the result. If you simply say that this is nothing but log 2 power 1, which will be 1. This is log 2 power 2, which will be 2. This is log 2 power 3, which is 3. This will be log 2 power 4, which is 4. And this will be log. When I say log, we will always assume the base is 2. Right. So for all these numbers, what we are simply doing is taking the log. Yes, Shubhi, you have to read. It will be a homework. It will be there in your references in the dashboard. So a link will be there. You can read about that from there. Awesome. Now, yes, what for the other numbers? Yes, so Dhiman has a very good question. What happens for the other numbers? So if you see for the other numbers, let's take the number 15. So what happens for this number? If you take the log 2 of 15, it comes out to be roughly 3.968. And you take the integer part of that. If you take the integer part, it will be 3. Right? So you simply have to take the log. It will work also for the numbers which are not powers of 2. For all the numbers which are not even powers of 2, it's going to work. Okay. Now why it works, the idea is same. We can prove it mathematically, but I do not want to go into it right now. We'll take a look at it in the next class when you read a bit about log, right? When we'll talk about time complexity. So what is the number of steps it takes? It takes roughly log n steps, where we will take the integer part only. Is it clear to each and everyone? For powers of 2, we proved it. For non-powers of 2, we did not prove it, but we will do that. We will do that in the next class. Does that sound good to each and everyone? Can you all give a quick thumbs up if that's okay? Let's move to the next problem then. Awesome. So log n is nothing but the number of times you need to divide by 2 to make it 1. So that's what log n is essentially. For log base 2, for base 2. So we have this base. Okay, fine. Let's continue now. So we'll talk about one more important problem now, which is in the first problem, we figured out that square root of n was the time complexity, was the number of iterations. So in this problem, this last problem for today, we are going to see how can we find out the square root. How can we find that? So we do not want to use the library, the inbuilt function. We want to build our own function. How we will do that? So one more important note is, like, after the session is done, we'll have a doubt session for 20-30 minutes where you can ask any questions. We'll take that up after this problem is done, which won't count towards your attendance. And also while watching your recording, your attendance gets updated, right? So that's the passive attendance, but we recommend you to watch live so that your doubts can be resolved, right? So let's talk about the perfect square and square root. So I'll have one quiz for all of you because before we solve this problem. Yes, Shanti, we'll talk about that as well. So first we have a quiz. Which of the following numbers is a perfect square? Awesome. So all of you got this correct. Kudos everyone. Amazing. Amazing. Avizita is 10 on 10. You're on fire, man. So let's discuss the final problem for the session. So you are given a perfect square. Yes, the notes will be uploaded, Deeman. Find its square root. So what we need to do is, this problem was asked in Amazon interviews. So it's an interview problem. Given a number, you have to find its square root. And square root will always be an integer since we have a perfect square. What's a perfect square? Perfect square is the one who has an integer square root. So for example, 100. What's the square root of 100? It is 10. So for perfect square, its square root when multiplied will give back the original number. So for 25, if you see, it is 5. 5 when you are going to multiply, it will give you the exact number n. So 49 was a perfect square in the quiz. Square root of 49 is 7. So 7 into 7 is 49. Now can you all tell me, Matisha, we do not want to use the inbuilt function. We do not want to use the power, right? That will work, but we want to build our own function without using the power operator in Python. Again, Bipul, we do not want to. Yes, Bipul, you are correct. Sorry. I want yes or no from everyone whether 30 is a prime number or not. Sorry, is a perfect square or not. Is a perfect square or not. No, right? Because square root of 30 will be something around, it will be 5 point something, right? Let's say it's 5.1 something. So when you will multiply 5.1 or something like that, will it give you back 30? No, not really. So it's not a perfect square because its square root is not an integer. Similarly, 24 is not a perfect square. It will be 4.9 something something. And when you will multiply that, you will get back the number. But yeah, it's not an integer, right? You will get back approximately that number depending on some factors. Okay. But it won't be an integer. Square root n won't be an integer. So you are given a perfect square only and you need to find out its square root. Okay. So very simple problem. All of you think about it. Think, everyone, think. Okay, Narendra, was that discussed in the beginner batch? Okay. Some of you are close, not everyone. Awesome. Don't worry, it will be a quick revision for those of you who already know this problem. Okay. Fine. So let's think about it. So what will happen here, if you will see, let's talk about the very simple solution. Very brute force solution. So what can be the range of square root? Can the square root ever exceed n? Can it exceed n? Not really, right? So what am I saying? It can't exceed n, right? So we can simply have a loop. So let's think about the brute force idea. So the brute force idea will look something like this. So we will see for a perfect square, its square root when multiplied, it's going to give the same number. Okay. So what we will do for 100, so we'll start from the number 1. Okay. We'll check whether the 1 into 1 square is equal to 100. Is it equal to 100? No. So we will continue. We'll check 2 square, whether it is equal. No. 4 is not equal to 100. 3 square, 9, no. 4 square, no. 5 square, no. 6 square, no. 7 square, no. 8 square, no. 9 square, no. Then when we come to 10, we will see that 10 square is equal to 100. Right? So can we return this number I if we say that I into I is equal to n? Yes, Matisha, absolutely. That's where we are coming to. Now, what is the time complexity of this approach? If all of you can see this code, take a minute, see this code, answer in the private chat. I'll launch a quiz after it. Yes, Leo Jos is the first one to get it correct. you are given that n is a perfect square. It is given that n is a perfect square. So it will definitely have an integer square root. So let me see how many of you get this. I'm launching a quiz. So how many iterations are required to find the square root of n in the current approach? Awesome. So there will be square root of n iterations. Why? Let me tell you. So what happens here is your I value will start from 1. It will go on. At what point will you return? When you will find the square root, you will return. So will your I ever go from 11 to 101? Sorry, 11 to 100? All that range will never come up, right? So what's the key point here is whenever you are going to reach square root of n, you will stop then and there itself. So what is the number of times your loop is going to run? It's not going to run more than square root n times. So this has a time complexity of, the number of iterations are square root of n iterations. So this will have square root of n iterations. Is this clear to each and everyone? Because we are given that it is a perfect square. We are going by this assumption. So whenever we will hit the square root, we will stop there. We will return there. Okay. Now, yes, Aditya, for perfect squares, absolutely. Even for non-perfect squares, we can do some small trick, but let's forget that for now. Okay. Now my question to you is, can we optimize it? Yes, Matisha, we can calculate the power. What you're saying is, can't we simply say 100 into 1 by 2 in Python? That will give you 10. But we do not want to use this. We do not want to use this. Let's say we can't use this. So we are trying to build our own logic, our own algorithm, our own steps to find the square root. Is this clear now what we are trying to do? Like in sorting, if you will build your own sorting algorithm, right? You won't use the inbuilt thing that is provided. Awesome. My question to you is, can we optimize this? Can we optimize this? Think about it. Gadiraju says reverse iterating, but we do not know square root of n. The point is we do not know this. We can't use the inbuilt square root of n method. We want to build our own methods, right? Okay, so yes, some of you know about power function. Forget about that. You do not have to use the power function as well. Okay, that works for integers. That does not work for 0.5, right? Half. Anyways, let's think about it. Let's start with 100. So if I want to check, let me give you a hint. So let's say if I want to check, so first of all, I want 100% response whether this is clear, why this has square root of n time complexity, iterations. Because whenever you will hit that, you will not cross the further loop iterations. You will stop there itself. Awesome. So now let's focus on a hint. Okay. How can we optimize? We want to optimize this code. So again, we will come to observations. What's the observation here? Let me say that I want to check whether the number n is equal to 25. I want to check, is it a square root of 100? Is it a square root of n is equal to 100? So how am I going to check? So what is the functionality? What is the property of square root? Let's say x is the square root. So x into x will be always equal to n, right? So can I check what is 25 into 25? It is 625. What do I want? I want 100, right? Based on this number, I know it's not a square root. It's not a square root of 100. Is there anything else I know about? Anything else I get to know about the square root from here? So if we write down the numbers, yes, Avijit. Yes, we know that 100, n is equal to 100 is less than 625, right? So if we can see, these squares will always increase. So what these are? These are the squares. If I write down, 1 has a square 1, 2 has a square 4, 3 has a square 9, 4 has a square 16. So this is always increasing, right? So this is always increasing. Okay. So basically, yes, Acharya, basically what happens now is 100 is smaller than 625. So that tells me that my square is going to come somewhere above, somewhere at a smaller value. So if I know 25 square is larger than 100, do I need to check 26, 27, 28, 29 till 100? All these numbers will always be greater, right, than 100. For sure they will be greater. So it tells me that, yes, Harpreet, it tells me that a range, so a range now where we can find the square root will now be from 1 to 25. Does that make sense? It will be now from 1 to 24, not even 25. Okay. Now, let's take one more example. Let's say if I asked for n is equal to 4, or n is equal to, n is equal to 4. Here what will happen? In this case, what's going to happen? 4 into 4 will be 16, and 16 is smaller than 100. So from here, do I need to check for 1, 2, 3? Do I need to check for smaller values? Yes or no? If I know that square value is less, so where I do need to go? If it is less, then I need to go for larger values, right? So I'll simply say that the range will be after 4. So we'll neglect. So here we neglected which part? In this case, we are going to neglect 25 to 100. And here we are going to neglect 1, 2, 3, right? Because 1 square will definitely be going to be 1 into 1 will definitely be less than 100 if 4 into 4 is less than 100, right? So from these two observations, first of all, my question to you is, from where should we start searching? If we are able to reduce our search space, what is happening? Earlier we were starting from 1 till 100. We are checking all the numbers. From where should we start searching and divide our search space so that we neglect the maximum portion? So my question is, how to neglect the maximum portion at each step. So if we have this range from 1 till n, so let's say if you start from checking here x, okay. So now it will divide into two parts, either from 1 to x or from x plus 1 to, 1 to x minus 1, x plus 1 to n. So you see that how many numbers are there in this range? So there are going to be x minus 2 numbers in this range, and there are going to be n minus, let's not go into this much maths. Okay, let's say that there are a numbers in this range. Fine. Just a moment. So in what case can we neglect the maximum portion? In any case, we want to neglect the maximum portion. So if you observe what happens here is, if you observe when we cut at n, when we check for when we check for n by 2, let me just get to the final answer now. See, when we get to the step n by 2, we check for n by 2. So what part are we going to neglect? We are going to neglect either of these two parts, either this n by 2 roughly or these n by 2. We are going to neglect 50%. If we had made a cut, let's say at somewhere else, if we had made a cut at the left part, let's say somewhere here, then let's say this is 25% and this is 75%. So in the worst case, we might have neglected a smaller portion. So if you see the maximum of both of them, we are trying to minimize. I know that statement can sound a little confusing, but having this at the middle point helps us eliminate the maximum search space. Okay. So don't worry, we will also go over in the session of binary search. So this is a binary search algorithm that we have come up with. Binary means we are dividing into half. So every time we are going to divide the search space into half. Let's see how it is going to happen. Okay. Yes, Abhishek, let's come to that. Aditya, Abhishek, Jagrut, let's discuss this. So let's take the same example 100 and write down these steps. Fine. We are almost near the closing. Do not worry. We are just taking a little bit of extra time. We'll quickly close it. So if you see for n is equal to 100, we will start from the number 50. Is my 50 a square root? How will you check if it is a square root? You will simply see what is 50 into 50. It is 2500. It's greater than 100. So where you will go? You will go to the smaller part. So your new range will become, now you are going to check from 1 to 49. Okay. So simply you are neglecting 51 to 100 is neglected. You have neglected half of the portion. Okay. Then here you will check for the half, that is 50 by 2. You will check for 25. Okay. So you are going to check for 49 plus 1 by 2, the exact half, which is 25. So 25 into 25 is again greater. So again you will go to the left half. So 26 to 100 is 26 to 49 is neglected. So now you will go to 1 to 24. The midpoint comes out to be midpoint comes out to be 12, right? So now you will check 12 into 12, it is 144, which is greater. So now your range will change from here to 13 to 24 will be eliminated. Sorry, 12 to 24. Right. So what you are left out is with this portion, that is from 1 to 11. The midpoint will now come out to be 6. So then you are going to check for 6. It is less than 100. So what you will eliminate this time? This time everyone please type it in the chat. What is it that you are going to eliminate? Which portion? From 1 to 6, right? So from 1 to 6 the portion will be eliminated. So now you are left out with 7 to 11. The midpoint will be 9. So you will check for 9. It is again less. So we will eliminate the start, that is 7. So every time you see the start and end, they are what we are manipulating. Okay. So we'll eliminate from 7 to 9. Okay. So then we are going to left out with 10, 11. That is 10 only, right? We are taking the integer division. So finally we will land at our answer. Here we can return it. So how many steps did it take us? How many steps did it take? All of you? If you see, this was the first step. This was the second step, third step, fourth step, fifth step, sixth step. So it took us exactly 6 steps, we can say, right? Wherever we checked once, twice, thrice, 4 times, 5 times, and 6 times. So it took us exactly 6 steps. So earlier it was taking how many steps? 10 steps, right? But still, in this case, it's not making much sense why this is working, right? But let's try to analyze first of all. Can we get the number of iterations now? Okay, can we get the number of iterations? Given a number n, can you find the number of iterations in general? That is what my question is. All of you think? So given a general number n, can you find the number of iterations where n is a perfect square? Okay. So the let's write the pseudocode or the very high level code, since we won't have that much time. So you first have to find the middle of the range. Okay, you will start with a range where both these values, low and high, will be updated. And your middle will be simply low plus high by 2. Fine. And once you are having that, you will check if it is square root. How you will check? You will check by simply checking mid into mid, whether it is equal to the number n or not. Fine. So then after this, you will update the ranges. If it is smaller, you will reject the left half. If it is larger, you will reject the right half. If it is equal, you are going to return the mid. Fine. So now with this step, you will keep on iterating. You will do this while the range is valid. Okay. While your low value is less than equal to high value. So try about it. Don't don't be stuck on this part. We will talk about this in the searching concepts later on. Till now, just understand the logic. I hope the logic is clear to everyone. Pseudocode, I'm giving it to you as an exercise for now. So every time we divide by 2, right? We divide this range by 2. The search space, if you see, it's getting divided by exactly half. So let's write down the range at every point. We started from 1 to 100, then it was 1 to 49, then 1 to 24. Okay, let me just change it a bit. It's 1 to 24. Then here it is 1 to 11. Okay, fine. Then it is going to be, just a moment. After 1 to 11, it is 7 to 11 and finally 10 to 11, right? So if you all observe very carefully, initially we started with the range of 100. Okay. 100 minus 1 plus 1, which is 100. That's n. Next time, the range that we are searching for, okay, it becomes 49 minus 1 plus 1, which is 49. Okay. Fine. And after this, it becomes 24 minus 1 plus 1, which is 24. Then it is 11. Then it is 11 minus 7 plus 1, which comes out to be 5. 11 minus 10 plus 1, which comes out to be. Did we miss any step? No, right? Which comes out to be 2. Right. And after this, what will happen is we are going to get our answer, that is exactly 10, right? Okay. Why we are doing this? Because we wrote down this formula, Vishal. The number of integers we get in the range a comma b is b minus a plus 1. Does that make sense? We just discussed it a little while back. Okay. So now if you see what exactly it becomes roughly, at the end we will be left out with only 10 comma 10. Fine. And we'll be left out with just one number, which is our answer. So I'm just writing it separately. So what this problem gets translated to is we start with the number n. Every time the range becomes roughly half. Okay. Let's consider this from 1 to 49 as a little bit higher side. Okay. So it's roughly n by 2. And then this is 49 by 2. So this becomes n by 4. This becomes n by 8. This becomes n by 16, n by 32, and this will be n by 64. So you see that it is n divided by 2 power 6. So how many steps did we take? How many times did we divide by 2 to make it 1? So now do you get the idea why did we discuss the previous problem? So every step we are discarding half of the range. In how many steps will we reach 1? If every time we divide by 2, how many steps we will reach 1? Log n number of steps. So now if you realize the power of this, then square root of 10 power 10 is 10 power 5. But log of 10 power 10 is 33.22. That makes it how much faster? That makes it how much faster? Can you imagine? So log n is way better than square root of n. So now is it clear how did we optimize? So this is how your internal square root function is implemented. It uses this binary search algorithm. So this is the famous binary search algorithm that we just discussed. And how did we come up with this? Can anyone tell me how did we come up with this? By using the only observation that we can discard some part. We can discard left half or right half when we are checking for a number whether it is a square root or not. Okay, Shubhi is asking from where log came into picture. Awesome. So let me repeat that part. And let me repeat the last part, Vishal. Vishal, I think that's what you're asking. How did log come into picture? Same question, right, Vishal? Okay, awesome. So, see, what happens is if we start from a number, let's say 1 to 1000. So you are going to check for the middle number. Let's say you will check for the number. This is 1 to n. You will discard exactly half of your range. Is that clear? Like you will check for the number that is 500, let's say. And either you are going to discard 12499 or you are going to discard 5012,000. At least one of these ranges you are going to discard. In this case, this one you will discard for sure. So what will be your updated range? It will be from 1 to n by 2. Okay, fine. So we are counting the range of numbers we are checking for in every iteration. So this will go on till we get exactly one number. Where did we stop? When we got exactly one number, that is the square root. Okay. So all of you pay very careful attention. This range, the low and high range, it starts from n, and every time if you see, this range becomes half. We have n by 2, we'll have n by 4, we'll have n by 8, n by 16. Every time it is getting halved. So how many times do we need to divide by 2 to make the range equal to 1? Since every step we are discarding exactly half of the range, we are checking the middle number of the range. Okay, so we are finding the middle of the range, and we are just keeping to loop it over and over. So it's the same problem. How many times you need to divide by 2 to make it 1? So what did we observe, Vishal, Shobhi, what did we observe earlier? That this comes out to be log n, right? So the number of steps we need to do to divide the number to make it 1 is log of n. And you have to read a bit about it. And we will do this proof. For non powers of 2 also, we are going to do this proof, how this comes out to be log n. Okay. Is this clear till everyone, clear till this point now to everyone? Awesome. Okay. Fine, Rishabh, that's something different. Yes, so let's summarize what we have learned today. So what we have essentially figured out is that observation is the key to be better at problem solving. Okay. And I'll give you just some real world examples. Let's say you go to the site amazon.com, you search for something there. Okay. You search for something there. Let's say you search for IP. It suggests you related keywords like iPhone, iPhone X, iPhone 13. So what happens there is a data structure, common data structure is used to give you these kind of suggestions. Fine. Then if you see the products, you will have a products page there. There you will be able to sort the data based on the price, based on the model. You will be able to apply some filters. So that's again a searching problem, a sorting problem you are solving, right? While filtering, it's a search problem. So when you have data which is sorted, it's easier to search in that data, right? So I'll give you one example. Let's say you are searching for a word in dictionary. The same concept that we discussed in this problem, you use while searching in a dictionary. You will check for a word. You will see the first letter. If it is greater than the word you are looking for, let's say you are trying to find out the word. Let's say you are going to find out the word car, and you are at the page that starts with D. So where you will go? You will go to the smaller left hand side pages, right? The ones which come earlier. And if you get to a page that starts with B, so then you will go to the right hand side. So use the same concept in real life when searching for word in a dictionary, the binary search concept. Okay. If you have seen when you do a undo redo or a back forward, so there's a stack data structure that gets used. You might do a lot of back and next operations in your browser, right? These kind of suggestions come with the help of a try data structure. So there are all these things that we will learn throughout this data structures module, right? In Facebook or LinkedIn, if you find mutual friends or degree of connection, that is with the help of graph algorithms, right? Finding the shortest path between 2 points. That's again something that comes for when we'll talk about graphs. So there are a lot of things here, and in every place we'll first have to make some observations, right? We will need data structures and algorithms just to be as tools that will help us formalize or come to better solutions, right? But you will have to be good at observations. So now let me tell you what all we will learn in this intermediate content. And just one more example I will give you. Let's say you are reading the book Concepts of H.C. Verma. Okay. You're reading any book. Say, for example, you might have come across this book when you are preparing for JE. So if you want to find out which page a word comes to, which page a word you can find on, right? So what do you do? Will you go through all the pages and search? No, you will see the appendix, right? Yes, Shubham. So what appendix does is, there you will find for every word, let's say you are searching for logarithm, you will see on which pages it belongs to. So there it uses a famous data structure, which is the hash map or the dictionary in Python. Okay. So all these data structures that we will learn, these algorithms that we will learn, they will help us solve these problems. But first of all, we need to be good at observations. So with that, what we will learn in this entire intermediate module, right? We'll learn how to be better at building observations. This is our main goal for these 2 months. So we'll start from time complexity in the next class. We'll have 2 sessions. We'll have 6 to 7 sessions on arrays, where we will talk about intro, prefix sum, carry forward techniques, subarrays, 2D matrices, interview problems. Then we'll have bit manipulation sessions, where we'll talk about bitwise operators. We'll have 2 sessions on maths, 1 session on sorting, one on strings, two on hashing, and there we will talk about what hash map is. So please wait till this point, right? In this session, we'll talk about hashing. We'll have sessions on recursion. Then we'll have one basic session on linked list, 2 sessions on tree basics, one on stacks and queues, and we'll have a couple of problem solving or miscellaneous sessions. So this entirely will be your 2 months content. Okay. Yes, we'll have more sessions on these data structures in the advanced DSA module. So your intermediate DSA module will help you get better at problem solving, observations, right? And some of the basic things that you need to know. Then whatever remains like uh, advanced sorting, advanced searching, two pointers, stacks, queues, linked list in advance, and then trees, BSTs, tries, greedy, DP, graphs, right? Heaps. All this thing will come to your DSA advanced module. And this is going to happen after your DSML or data science module gets over, right? So this is the entire roadmap. This will be roughly 4 to 5 or roughly 4 to 5 months, but it will happen after your DSML. So this is the entire structure. I hope it makes sense to each and everyone. Avjit, it is not right after intermediate because you people are in this data science course. So we will focus on that. So after this basic DSA, that much will help you. That much will help you in getting the feel of algorithms and how do you come up with ideas, observations. Like how did we solve today's 2 or 3 problems, right? So that's it from today's session, everyone. I'll just summarize a few more things just to wrap up. The notes will be uploaded. We'll have assignment and homework problems which you have to solve in Python. In a week, we will have roughly 20 problems. So in entire 8 to 9 weeks, we'll have around 160 to 170 problems that will all solve. So for assignment problems, they will be like the ones we discuss in class. Homework problems will be slightly tricky. We'll have problem solving sessions at the end to discuss those kind of problems. Okay. So now, how do you ask for help if you are stuck in a problem? So when you will solve assignment, you will get doubts. So how do you make sure that you resolve that? Now there are 3 steps I'm going to tell you. First, try it yourself for 30 to 40 minutes, at least 30 to 40 minutes. If you don't understand, ask TA. You have a TA doubt resolution feature in your dashboard where you will get on a one-on-one call with a TA and they will resolve your doubt very soon. So the average response time is going to be very less. So you can ask them to help with the logic if you are stuck in the logic, debugging your code if you are stuck with that for a lot of time. All those issues you can ask to your TA. Now, if you have a conceptual doubt or session doubt, what we discussed in the class, then you can ask it in the session. Like we'll have doubt session for 10-15 minutes in the end. Generally, we will end by 11 p.m. So today's session is a little lengthy. Generally, we will finish by 11. And then we have 20 to 30 minutes for just doubts. In between the session, I always answer doubts if they help you get unblocked at that point, right? But if that still is not answered, you can ask it in the doubt session at the end of the class. Otherwise, if still you have some doubts on concepts or the session, you can message me on Slack. This is the last option, right, that you have to resort to. Is this clear to everyone? So you have to follow this 3-step process if you get any doubts in any assignment, homework problem, in any concepts. Awesome. And one final thing, you have Python primer in your dashboard, all classes, optional classes. If you are looking to refresh your Python concept, just go over there and watch those sessions at your own pace. Fine. It's for those who are starting with the intermediate module. Sorry. Avijit, you can see the assignment questions right after the class. They are there in your dashboard. They are already uploaded. You can start solving them. So your sessions will be on alternate days. Your sessions will be on Monday, Wednesday, Fridays from 9 p.m. 9 to 11, we will discuss the content. 11 to 11:30, it will be all doubts. Matisha, Python is not going to be taught since the beginner batch has been taught Python. If you are very new to Python, then there are 2 things. First, the primer material, the refresher material is there in your dashboard. All classes, optional classes. Just go over there, watch that content at your own pace, right? And second is if it is needed, in the worst case, you can start from the beginner batch, December beginner batch. If you know very little of Python, you can go there. Okay. Awesome. Yes, Anshu, those are Python problems. In the assignment and homework, we'll have questions related to the current session. Fine. So now one more problem was there. Deepti Krishna, class notes will be uploaded. When you will watch the recording, you will see another tab in the right side, another icon for the lecture notes. So you'll be able to find it within the recording itself. Okay. Awesome. So thank you so much for attending, everyone. If you still have any doubts, you can stay back. I'll start the doubt session now. Good night, everyone. Take care, and let's see you all in the next session on Wednesday. So I'm starting the doubt session. Thanks everyone for attending. Have a good night. Sleep. Take care. See you on Wednesday. Let's start the doubt session. If you have questions, stay back. So, Gadiraju, Venkat, Pawan, Teja, Tiwari, is there a possibility of morning sessions? That's totally not possible depending on the majority of the class. So, sorry about that. Actually, we have most of the people who have voted for this timing. So, that's why we are going with this, right? Why can't we use cube concepts instead of square? Yes, Venkat, we will discuss that in binary search. Why do not we divide it into three parts or something like that? So it's a very good question. We'll discuss it in binary search in the advanced content. Dhiman, assignment questions will be there in your dashboard itself. Let me take up any other questions. Uh, please ask questions in the questions tab only. Otherwise, I'll miss them. I'll miss your questions if they are not in the questions tab. I'm just looking at the questions tab right now, all of you. I'm not looking at chat. Vishal is asking, how do I ace my DSA? Do you think hand holding like this will improve? No, Vishal, we will discuss how you can come to the solutions in the class. We discuss how you are coming to the solution. So you apply that observation skill that you build in the classes, right? Then only it will improve your problem solving skill. You just have to attend the classes, have to think, have to solve the problems after the classes. You have to put in a lot of efforts, Vishal. Then only it will improve. Okay. Beginner module, as Dhanush is saying, it is 15 sessions. So it will take you roughly 1.5 or 2 months. I think it will take you 1.5 to 2 months, right, Dhanush? Okay. How much time per question should be dedicated without asking to help? Rishabh, at least 30 to 40 minutes per question. Rohit, there might be some problems which can't be optimized further. Okay. Sai Deepak, we will share the questions, extra questions in the extra references section in the dashboard. Okay, Sai Deepak. But please finish the assignment and homework first. Gaurav, very basic knowledge of Python should be good enough. If you are able to write functions, loops, conditions, and able to use the inbuilt methods, that's good enough. Shubhi is asking, how do we improve our observation skills apart from classes? You have to solve problems after class. So don't just forget what was discussed in the class. You have to revise the notes before coming to the next classes. So you need to spend that time. Okay. And maybe, so I would suggest that you start, if you have time, there are some online platforms where you get like if you somebody does competitive programming or somebody have heard of it, so you might start giving some contests on some platforms. Okay, that can also help you to be more time bound in your practice. And we'll also have contests after every module. We will have contests where you will be judged or you will be tested, and like it will be a revision for you as well as a point where you can judge yourself how well you are doing. Okay, so just keep practicing. That's the only thing. Dhiman, assignments are not time bound. Okay. Anu, it is there in your dashboard itself, external material. It will be there, extra references. Yes, yes, Srinath, that is the absolute correct path. Yes, that's it. Vishal, you can complete it anytime, but try to finish before the next class. Awesome. So yes, Swati is asking, could you please show the steps for square root for 49? Yes, yes. For 49, let's get to it. So for 49, what we will do is, we will check for the number 25. So is 25 square greater than 49? Yes, it is. So we'll go to the smaller part. So now we are going to go from 1 to 24. The middle number is 1 plus 24 by 2, which is 12. So 12 into 12 is going to be greater. So we'll go from here to 1 to 11. 1 plus 11 by 2 is 5. 5 square is actually smaller than 49. So we'll go from 6 to 7. And 6 plus 7 by 2 is, if you see, it comes out to be 6 only. So 6 into 6 is going to be less than 49. So we'll go to 7. And finally, we'll have 7 plus 7 by 2, which is 7. 7 square, which comes out to be 49. So we stop here. So these are the steps, Swati, that we did follow. Okay. Awesome. Okay, let me tell you, if you want to practice some competitive programming, definitely you can, but I'll not suggest that before you solve the assignment and homework. Like, first finish the assignment and homework problems. After that, only try these platforms. Like, you can solve on Code Forces. So this is one of the platforms that I used to do. It will help you be better at observations. You should try for, there are two divisions here. Try for division to A and B problems. Okay, these are the A and B and C after. So after you finish this module, you will be able to solve these three type of problems. If you see in Code Forces, division to A, B and C type of problems. These are the ones that require observations or these concepts that we have discussed, that we have listed down. Okay. All these concepts you will be clear after the intermediate module, and you will be very much confident in this. That's what I guarantee. If you stay in the classes, if you solve the problems, definitely you will ace it. Awesome. So I'll not suggest many other platforms. If you want to know about that, like, you can ask such out of the class questions on the Slack as well, if possible, right? Similarly, Abhishek, I'm working on Django REST framework. Could you suggest best? So Abhishek, for that, please message me on Slack. I'll respond to you separately. That's like out of context. Okay, awesome. Any other questions we have? No. Fine. If there are no other questions, thank you so much everyone for attending. I'll upload the notes and see you on Wednesday. Tata. Bye bye.